the effects of the genetic variance for each 10 risk allele increment on the incidence of obesity in the next 4 years, stratified by the levels of SSB consumption. The results are quite consistent across the 3 cohort studies. In the pooled analysis, as you can see, that each 10 risk allele increment was associated with about 30 to 40% increased incidence of becoming obese in the next 4 years among non-obese individuals. However, among those who consume SSBs on a regular basis, at least 1 serving per day, the relative risk increased to 3 to 4-fold. So it means that if you carry additional 10 obesity risk alleles, and if you drink SSBs on a regular basis, your risk of becoming obese is amplified and to almost 3 to 4-fold. So this is a significant and I think clinically important, meaningful interaction between SSB consumption and genetic risk, genetic predisposition to obesity. Based on the current evidence, many organizations have made recommendations to reduce added sugar intake, especially reducing consumption of SSBs. In 2015, the WHO developed guidelines on sugars intake for adults and children. So the WHO, before they announced the guidelines on added sugar intake, they commissioned a meta-analysis on added sugar intake and weight gain and obesity. The meta-analysis commissioned by the WHO found that adults who reduced their sugar intake, reduced their body weight, increased their sugar intake associated with increased weight gain. And also there is strong evidence that SSB consumption is associated with childhood obesity. So based on the evidence from the meta-analysis, the WHO made a strong recommendation that adults and children should reduce daily intake of free sugars, which are mostly added sugars, to less than 10% of the total energy. The meta-analysis also found a strong association between sugar intake and high rates of dental caries. So that's one of the another outcome, health outcome, that the WHO looked at when they developed the sugar guidelines. The WHO also made a conditional recommendation that further limiting added sugars to below 5% of total calories would provide additional health benefit. So why this recommendation is conditional? Because this recommendation is based on much weaker evidence, ecological evidence on the association between reducing added sugar intake and the dental caries. So the evidence was much weaker because it's mostly ecological. The American Heart Association has made strong recommendations on added sugar intake for children. The HA recommends that children should consume less than 25 grams of added sugar or 6 teaspoons, no more than 6 teaspoons of sugar per day. And children less than 2 years old should avoid added sugar. The 2015 and 2020 dietary guidelines for Americans have also made strong recommendations on added sugar intake. And this recommendation was based on the 2015 Dietary Guidelines Advisory Committee scientific report. The committee conducted a systematic review of the relationship between added sugar intake and a wide range of health outcomes. The committee concluded that there is a strong evidence between higher intake of added sugar, especially SSBs, and increased risk of excess body weight and obesity, as well as type 2 diabetes. There is moderate evidence for increased risk of hypertension, stroke, CHD, triglycerides, and dental caries associated with regular consumption of SSBs. The committee also concluded that there is moderate evidence to support the potential benefits of replacing SSBs with low-calorie sweeteners or artificial sweeteners, caloric intake, body weight, and adiposity in short duration studies. However, there is limited inconsistent evidence of the association between no-calorie sweeteners and the long-term body weight control and risk of type 2 diabetes. So based on this evidence and the scientific report, the 2015 Dietary Guidelines Advisory Committee made a recommendation that individuals should limit their added sugar intake to no more than 10% of the total calories. So this recommendation is consistent with the WHO recommendation, and this recommendation is supported by both the current scientific evidence and also by the food pattern modeling analysis conducted by the DGAC. The Dietary Guidelines for Americans actually emphasize the quality of overall diet or the overall eating patterns, even though it made strong recommendations on limiting sugar intake, limiting saturated fat intake, and limiting sodium intake. But the main emphasis of the Dietary Guidelines for Americans is to improve overall quality of the diet and improve dietary patterns. So I think it's very important to consider sugar reduction as part of the strategies to improve overall quality of the diet. In addition to limiting added sugar intake, there is also strong scientific evidence, strong rationale to limit saturated fat intake and sodium intake. The 2015 Dietary Guideline Advisory Committee also made several policy recommendations to limit SSB consumption and reducing added sugar intake in foods and beverages. So these recommendations include promoting water as the preferred beverage choice, including added sugars in the nutrition facts panel, exploring front-of-package labeling strategies, continuing reducing added sugars in foods and sugar-sweetened beverages in school meals, limiting marketing of foods and beverages high in added sugars to children and adolescents, and also investigating economic and pricing incentives to promote purchase of healthy foods and beverages. As you may know, most of these recommendations have not gone anywhere because those are all very challenging political issues. However, the recommendation on including added sugars in nutrition facts labels was actually approved by the FDA in the revised nutrition facts panel. So one of the main changes in the revised nutrition facts label is to add a new line on the amount of added sugar in foods or beverages. So currently we only have total amount of sugar in the food labels. We cannot distinguish natural sugars and added sugars. Now we have both total amount of sugar and also added sugar in the food labels. But the implementation of the revised nutrition facts label has been delayed from 2018 to 2020 for large companies and 2021 for small companies. So going back to the key questions I posed in the beginning of my talk, I think we have made a lot of progress in generating evidence and the data to address those questions. Of course, we still have a lot of work to do to investigate the relationships between added sugar intake and various health outcomes. And also, we need more data on sports drinks, different types and different forms of fructose, and also fruit juices, because not all fruit juices are created equal. Some fruit juices contain more sugar than others. Some fruit juices contain more beneficial nutrients than others. And also, we're going to have a session tomorrow to discuss diet sodas or artificial sweeteners. So in summary, intake of added sugars remain very high in the US population, and half of the added sugars come from beverages. There is strong evidence to support the harmful effects of added sugar intake, especially SSBs, on obesity and a wide range of health outcomes. The fructose portion of the sugar is not only the culprit, because we talk about the nuclear calories, we talk about the high glycemic load, and we also talk about the unique metabolic effects of fructose. So I think there are multiple pathways or mechanisms through which SSBs or added sugar that impact cardiometabolic health outcomes. And it's also very important to look at the different forms of food sources of sugars and fructose. As I mentioned earlier, the different food sources of fructose can make a difference in the risk of type 2 diabetes. It is appropriate, based on the current evidence for the current guidelines and policies, to target reducing total added sugar intake and the SSBs in particular. However, reducing sugar intake should be part of the strategy to improve the overall diet quality, which include increasing fruits and vegetables, whole grains, legumes, and other plant-based foods, and limit processed meats, sodium, and saturated fat. So when we talk about the strategies and policies for reducing sugar intake, we cannot lose sight of other parts of our diet. So thank you very much for your attention. I forgot to acknowledge my colleagues from the large cohort studies. Okay, so I think I have 3 minutes, 50 seconds left. Any burning questions? Okay, all right.
Can I ask you to comment? Let me give you sort of an alternative interpretation of the data, which I know won't be a popular one here. And that is, so you showed relative risk for consuming sugar-sweetened beverages and low-calorie sweetened beverages to be identical. Doesn't that suggest that it's not the sugar, nor is it the low-calorie sweetener, it's drinking?
Well, so you really have to look at the relative risk after adjustment for baseline BMI, because that adjustment made a huge difference. So as I mentioned earlier, adjustment for baseline BMI attenuate the relative risk for SSBs by 1/3, and you can argue that baseline BMI may be a confounder or mediator for the SSB association, but even after adjusting for BMI, there is still quite a robust, consistent association for SSB. But for ASB, almost 80% of the association was attenuated after adjustment for BMI. The reason is that at baseline, overweight and obese people have much higher consumption of diet drinks than normal weight people.